Okay, hello everyone. Once again, I'm Nicolas Féjean from VG Police Valley and coordinator of Track Project. We welcome you with pleasure this morning to this webinar about ICT for agri-food. I will let the floor to Mr. Carnevali for this hour and a half and maybe 1/2 hour or some minutes to have your question and the answer of Mr. Carnevali. So I let the floor to him now, and thanks for being here. I'm sure that more people will connect soon. So Mr. Carnevali, the floor is yours, and let's start.
Thank you, and welcome everyone. My name is Massimo Carnevali. I'm teacher at the FIR University, but I'm also an ICT consultant, and I'm the cluster manager of the innovation cluster in Emilia-Romagna. Everything that I'm going to say in this webinar is only my own opinions. I'm not talking as a cluster or as my university. Is my opinion and my view as ICT for agri-food. And as I said, I'm an ICT consultant. I'm a long experience in the ICT world, and also spent 3 years in the MAC Foundation in San Michele all'Adige, which is a research center for agri-food technologies. So it's where I learned some of the stuff I'm going to talk about in this presentation. I don't know if you have any problem, you cannot hear me, or I'm not a native in the English language, so maybe that I will also make some confusion, some mistakes. So please feel free to chat and say slow down, or that was not clear, or something like this. And as far as I know, there will be also a Q&A at the end of the presentation, so you can also keep your questions, and then we will have the space for a small discussion at the end of the presentation. And I see that someone else has joined the conversation, so I will start. Okay, that's me. The first point that I wanted to, well, it's not going, I don't know what you think you are going to listen in the next 1 hour and something more, but I'm not going to talk about single technology. I mean, I'm a technologist, but I know that every problem you're going to assess in every field, there is not a single technology that is going to help you to solve all your problems. Using ICT to go inside your industry and to grow agriculture and everything else, it means that you don't only have a single technology that will solve your problems, but you must consider everything in the view of the whole ecosystem, because there are no isolated technologies. We are going more in deep in this later, but I think that you always have to have a view, 360 degrees view of the technology to go inside your problem. Let's start with an example of this. I mean, in the agricultural field, you start from the field, and in the field you have a sensor and you have actuators, because you must see you must see the temperature and the humidity level of the ground, and you have a lot of sensor in the field, and you have also actuators, because maybe you want to regulate how much water is going on the field, or all other stuff that must be governed from the central point. So you start from sensor and actuators, which is the starting point, and these, of course, produce data. The sensor relieve you have a lot of data, you have a lot of sensor, so this means a lot of data. And also actuators can give you back information on how many water, for instance, they irrigated, stuff like this. So start with sensor, you take off from sensor data. Then when you have data, you must analyze this data. At least once you must analyze this data, because otherwise it's not useful to have all of this data. And you have sensors that are giving you data, so you must analyze them. And that's the next step. And you must understand this data. You must understand what this means. And from the understanding, you take decisions. So based on these decisions, you go modify what your actuators are doing, and maybe you're going to add some more sensor, or you have to add more information, and you know that, for instance, you're collecting data, but you are missing some data, and you discover this when you go to the decision point, and you discover that you're missing some fundamental information, and so you add sensors, or maybe that you discover that you must add some chemical, and you must add the actuators to irrigate this chemical. So it's a loop. You're going inside this loop, and it's a continuous improvement loop. And why I started from so far, because this slides gives me the opportunity to show the ecosystem of the technologies. Of course, sensor and actuators are the field of IoT, Internet of Things, and this is kind of stuff that is in common with nearly every industry. I mean, if you have mechanics, or you have, if you have agri-food, or if you have chemical, you always need sensors and actuators, and that's the field that in the technology view is called IoT, Internet of Things. Then this IoT gives you big data. I will go more in detail later on what I mean is big data. Maybe it's my view, but maybe it's something that can be interesting to share. Because the more sensor you have, the more data you receive, and you go in the field of big data. Then when you have big data, you must analyze them, and it's what is called in the ICT field is called data analytics. With data analytics, you try to extract the meaning from data. Data by themselves are not useful. It's useful when you start having meaning from this data. And data analytics is the ICT science that helps you to extract meaning and information from data. Then probably you will have, in recent time, you will have to use artificial intelligence, machine learning, deep learning, and this kind of stuff to from your data to extract more information, to individuate, to find patterns that are that reply to the data, and you must teach machines to learn and say from what is normal. Intelligent machine learning is normal based on this decision, and usually have systems that are called decision support system, which is upper left, which is the software and maybe sometimes hardware that helps you to take decision. And sorry, there was a chat. I was distracted from the chat. And if it's something that I must answer immediately, please tell me, because okay, maybe something is not going on the screen or on the video, say in the chat. I will take a look at the chat. I was saying that decision support systems are the systems that helps you to, based on data, take decision and take actions. So going back to the beginning, with the decision you took, you can choose actions and implement these actions using actuators. This is the picture that I usually take when I usually take with me when someone says I want to talk about ICT for agri-food, for green tech, for something, and say, okay, you're not going to use a single technology. You must have a clear idea of what is interesting, is important in your field, and we must go through all of this information. In the center, I put cloud and TLC, because of course now we are in a connected world. So maybe you have the need to control a field which is not near, so you have to put your data in some way in the cloud using telecommunication technologies. So cloud system is what's cloud architecture is what's inside this loop, because it's the way you use to connect all your data. It's not more the time of staying inside a few hundred meters. Maybe now you can have information going all around the world, and maybe you can have your sensor and actuators that are somewhere in the world, and you want to connect the data and take decision in central point, which is far from the data. So you need also to have a clear idea of what is the cloud and what is your TLC necessity. I mean, it's SIMs, if it's 5G or what you need. That's just to give you a first quick overview of what I mean with technology for ICT for agri-food is an ecosystem, it's not a single technology. Let's start with one of the, I think, I will not go in deep all of this technology, I will just take a couple of them just to go more in deep, and I try to give some more practical information of what was, of the methodology. I think it's important. I think I'll try to transfer more a methodological view instead of the technological view, because I think that you can always find a great technology people that helps you go in deep in artificial intelligence or IoT, but usually what remains in charge to you is the methodology and the way of using this. So I will not go too in deep on the technology, but just more information. I think that, for instance, I will start with big data. Big data, in my opinion, and I think in the main literature, is big data only when you have volume, velocity, and variety, or at least one of this. Volume, I mean, that's easy. It's big. So volume is you have a lot of data. And now it's very easy that this happens because the sensors are very low price. You can put sensor everywhere, and you can put a lot of sensors that collects a lot of data, and it's very easy that you start having a big volume of data, and you must start with the technologies that are known as big data, because you can handle this data with the normal software technology, I mean. But it is not the only way to think of big data volume. The second one is velocity. Velocity, I mean, sometimes, sorry, sometimes you don't have big volumes of data, but you have data coming very quickly. And it's less known as an item, but it's also a meaning of big data. I mean, sometimes you have real-time data, and you must react very fast to this amount of data coming. So maybe they are not too much, but they are very fast. And so also in this case, you cannot use the normal software methodologies and the normal data analysis, but you must use technologies that are in the field of big data. The third and probably also less known way of thinking of big data is variety. Variety means that it's very easy if you are measuring a temperature, because temperature is something that in field can go from -27 to +43. But sometimes you receive data that is not so easy, is not so structured. So maybe you receive unstructured data. Maybe you receive a picture. Maybe you receive text. Maybe you receive a sound. And this is not structured data, it's unstructured data. And maybe that also you have a discontinuous flow. I mean, when you measure the temperature and you say take the temperature every 30 seconds for all day, you know that you're going to receive this number of data. But sometimes, for instance, you have data that are flowing in a different speed, different sampling speed. Maybe that you usually need a 5 minutes step, but when at the beginning of the day or at the end of the day, or when it starts raining, you want to collect data at 5-second rate. And this is variety, is data coming in a discontinuous flow and in a different sampling speed. And you cannot handle this data with the normal way of handling data. You must use technologies that are inside the big data field. So in my opinion, you can talk of big data if you have at least one of these three problems. If you have all three together, I think you're in a big mess, because it's not easy to handle it. But if I have one of this V, the 3V of big data, I think that you must start using the big data technology. You must find a very good big data analyst and work with them. And you know that it is changing the game. It's not the same game that you are playing when you're doing your payrolls, or you're doing your banking account, or you're doing your normal software analysis. Then there are other two V, and it's veracity and value. I mean, veracity, it seems easy, but sometimes it is not considered at the right value. I mean, veracity means that you can trust the data you are receiving. Of course, say, okay, that's easy. Of course, I trust my data. It's not as easy. I mean, I've seen a lot of situations of someone putting sensors, but not being really sure of the error value that they are going to have. So you must be sure that your data are collected in the right place, in the right way, at the right speed, and the data you are receiving back are the right data. It is something that is implicit, but you must check it. And then the other one is value. Of course, this data must be a value for you. And maybe it's not a value now, but you must consider that maybe in 6 months from now, the data you collected now is going to be important, is going to have a value. So if you have at least 3 of the first V, volume, velocity, and variety, one of these 3, and both of these, so veracity, so real data, and value, something that now or maybe in the future can be of a value for you, then you can start using technologies called big data. And you can call a big data specialist. And don't try this at home, because it is not easy. But it's the field when you can start using a lot of data. Let's just check a couple of practical uses of big data. These are some samples that I think I found as used by people nowadays, and where at least it's always the sample, the 4 sample I'm going to talk about as at least one of these, and surely both of this. I don't know if you've seen my hand. But. So first sample may be food safety and traceability. Of course, this is a very strong point now, and everyone is talking about this. And no, is not. You're not going to solve this problem only using blockchain. I will talk about this later. I mean, I've seen too many information, misleading information about this. I think that food chain is something that works when you have blockchain and sensors and data analysis, etc. And I will talk later of blockchain, because there is, I think, a lot of misleading information on this. But of course, food safety is a classical field where you have a lot of data, a lot of sensors, and you must use the data correctly. And using big data and what is artificial intelligence and machine learning, you can find anomalies. And that's the great advantage of big data, is then when you have a lot of data and you can handle this, and you have what we call a baseline, and you know that the baseline of your data is this. If something changes, you can, from the deviation, you can understand that something is going wrong. And this is a classical field where big data and data analytics and machine learning are a great help of you. Then the second one is yield forecasting. And this is a classical field for big data, because how do you create yield forecasting? You create mathematical models about weather, about chemicals, about terrain, and about fields. And from collecting all this data using the right models, mathematical models, you can have a good yield forecast. And I mean, mathematical models usually means a lot of numbers, a lot of number crunching, and this is another classical way of using big data. The third one, I think, is risk management. And risk management is what is the chance of abnormal events. For instance, you can of course, an event that is abnormal is something that by definition is out of the prediction range, but you can have risk management. I mean, you can say the probability is like this. So, for instance, I can handle storage management based on what is risk management. From the yield forecasting, from the big data, I can construct a model. From this model, I can have a prediction and an analysis, but I can also try to build a risk analysis of what is maybe it could happen of abnormal. And based on this information, I can, for instance, I can manage storage, I can manage my warehouses based on this. The last one, I think, it can be the equipment management. When you have a lot of equipment, you can have equipment allocation, maintenance. Usually, you can also have what is called a predictive maintenance, because you're analyzing the data of what your equipment is or your equipment is doing. You can have an information of when probably you're going to manage the maintenance. And so you can also build models of this. And of course, I think in this last sample, there is also what is called the UAV, the automatic, unmanned automatic vehicles, which is now I think is growing very, very fast. Probably not on the road. I don't think that we are going to see unmanned car driving, self-driving car in the near future, but in the fields, I think we can see the unmanned equipment in the near future, really, or at least they are already here. I mean, everyone has a Roomba in his house, and we know that the equivalent of Roomba that can go in the fields. And this is something that is also related to big data, because to have something that moves in an autonomous way, it must have a lot of sensor on board, and it must analyze all the data produced by the sensor that can understand if maybe there is something that is in front of the vehicle. And this is a lot of information we must manage, and this is a field where big data comes very strong. And when someone says we are in the first revolution, I think it is not the first one. This is a slide from Gates Foundation, and it tries to individuate with the previous revolutions and to try to insert also this revolution is box. We started from the Green Revolution in the 60s, 70s, and maybe biotechnology revolution in the 2000. And now is, I think, what is called ICT and mobile revolution. And of course, the main benefits, for instance, is access to input and product markets. And the great impact is the market information system and the translation costs. But that's just to say that it's not the first time that we are in front of a revolution on this field. This is technological one. Okay, I think that the last 3-4 slides are going to be stay more on the screen because there is more details, and I try to make a kind of checklist of the agri-food challenges, ICT for agri-food challenges. And this is what I talked at the beginning was my vision of the methodology. I mean, of course, there are technologies, but what are the challenges of using in the right ways these technologies? First one, I think, as we were talking about big data, is the smart use of data. It is a great challenge, in my opinion, because you must have very clear where are your data, and maybe this is not as easy as you can think. There is also a specialization of people that helps you to find your data, and maybe that you must also try to understand which data are going to be useful now and which data is going to be useful in the future. So you must take this data, put them away, because maybe you want to make a long-term analysis, and maybe in 6 months you're going to need this data that you collected today. And this is one of the fields where ICT for agri-food is different from other ICT for mechanics, mechatronics, for instance. Because usually in the other situation, you collect data and probably you're not going to use in 6 months the data you collected today, because the situation is going to change a lot. ICT for agri-food, I think that there's a big challenge to understand well what data to take for the future. And of course, you must think of this because you must start collecting them now, maybe to use them in the future. So you must justify the expense of collecting this data, and that's not an easy part of the challenge. But it's something that you must, I think, you must think now. The second point is the data sharing along the chain, and this is something also I think is very new. Now you must, how can I explain this? If you are a producer, you produce wine, and till a few years ago, data were your data. I mean, you have the information of where your grapes are, when you collect them, and in which bottles they finish. And that's your information. Now it's not the same, because I mean, the data has gained a value also for the final customer. So now it's very easy to find on a bottle the indication of the exact point in the field from where the grapes were collected. And that means that now data is shared along the chain. I mean, the chain is from the field to the table. You must think that your data can be interesting in all these points, from the field to the table. And this means that you probably have to think about cloud infrastructure and maybe ad hoc social information. People now used to go to social networks to have this kind of information, and this is important because if you understand which data you can share to improve the value of your products, it's something that can be very, very interesting. But this is also an analysis you must do, and decide which data collect for you, which data must be shared along the chain. And which are the instruments, which are the cloud instruments, which are the social instruments, which are the technological instruments, and something also in this case is a 360-degree view of the data analysis. Third point is new decision-making apps models. I mean, decision-making, as we told before, you enter in the decision-making fields when you have the decision support system. And how can you make a decision if you don't have enough data? And you can have machine learning, artificial intelligence that helps you to make decisions, but it's something that must be trained. When we talk about machine learning or deep learning, is something where you take a lot of samples, you give all the samples to the machine and say, for instance, if you want to train an artificial intelligence to understand, for instance, a good leaf or a leaf which has some problem, which is ill, is not safe. You show a lot of picture of good leaf, and you show a lot of the picture of not good, and then say the machine learning, okay, now look you at the next leaf and say if it's good or if it's bad. This in extreme synthesis is what machine learning is doing. And of course, you understand that you must have a lot of data to train the artificial intelligence. And the more data you give, the more good data you give, the more the artificial intelligence can be a precise help for you in making decisions. And ICT for agri-food is just started. We don't have a lot of training data, so it's something really new. We must create new models, new apps, and collect a lot of data. And for instance, with this data, you also create stochastic models, for instance, for weather forecasting, and this is another situation in which agri-food is different from mechanics or from other ICT fields, which is in mechanics you don't have a lot of stochastic models. You might have more precise models. You have machines, so you can better understand how it works. But when you are in the field of weather forecasting or field forecasting, this is very different. And which means that a new generation of decision support system must be created. And the new decision-making apps and models will be created only if there is a market for them. So it's something that is going around. If there is no market, there are no models. If there are no models, there is no market. But it's something that is going to break now. And if you that are listening to this webinar are in this situation, you can push all the decision maker and help grow this. Because if there is no push from the market, there are not going to be new decision making apps or models, and it's going to grow at a lower speed. Another challenge, so this is a summary slide that maybe is the focus of the presentation, but it's something that is I try to put down all this list from what's my experience, what is my mind, what I saw around, and so that's where this checklist comes from. Another one is self-contained sensor and actuators. This is more also something that is peculiar of the agri-food challenge. I mean, when you are in, for instance, in a factory, in a mechanical environment, you have power, and it's not a problem to give power to a sensor. But if you put a sensor in a field, there is no power. So that's the meaning of self-contained. I mean, when a sensor that must be used for agri-food must be able to have its own power, or to receive power from the sun or from something else, and that must have the telecommunication information inside. So it must be able to talk with the other sensor and with the central point of collection, which is very different from what is needed from the mechanical, for instance, or from someone that produces packaging machines, because they have the power, they have the connectivity on board. So this means that the sensor and the actuators for the agri-food must be different. So it's something that must be created. There are now, of course there are, but of course is also a market that is growing at lower speed from the sense of for the mechanical market, because there is this need which is very peculiar, and this is something where I hope there will be more hype from the industry, because it's something that is going really to be a change maker. Because from the data, we are not going to have big data if you are not going to have big sensors and big actuators. And to be effective in the agri-food market, they must be self-contained. Of course, the other information really connected to this one is the connectivity item. I don't know if you can see my hand. I try to point with my hand. But connectivity, of course, is the next point. Going again in the mechanical sample, if you are inside the factory, you have connectivity, you have a cable, you have a fiber, you have everything you want. And if you have a sensor put somewhere in the middle of nowhere, or on top of the mountain, you must have connectivity, which is not so easy to have, maybe sometimes, because if you usually if there is a field, there is agriculture, there are no people around, and so the companies that are creating connectivity see that this is not a profitable place to bring connectivity. So maybe sometimes you must rely on connectivity that is going for other reasons. So, but if you are very far from the houses, from the cities, from the points where the people is and where the money for the TLC is, maybe you're going to have problems with connectivity. And probably what will be a game changer for this is a 5G technology, because with 5G technology, you can cover, beside the speed, that is not a problem. For instance, sensors are not going to have a high speed need, but they're going to have a reachability problem. And with 5G, you can go very far, and sometimes you can also have a very narrow beam to, I mean, it's called illuminate in the technology way. I mean, you can bring connectivity in a very narrow place, in a very precise way, and say, I need a 5G signal on top of that mountain, and you can reach it. And 5G has this kind of capability that current technology are not going to help. So connectivity is going to be one of the next challenges, especially when your field is not very near to the houses or to people, to where people live. All of this, of course, comes very easy when sensor and actuators goes down on the price. You have a lot of new, I mean, not so new, but you have Arduino, you have Raspberry Pis, you have a lot of openness instrument that can help you to create a low-cost sensor and actuators. If you must put a lot of them, you must have something that is not very expensive, and but must have all the characteristics that I told before. I mean, must be self-contained, must be reachable with an easy connectivity, and must collect a lot of data. And it's something that has a very low maintenance request. You must not go every 5 days to change a battery, of course, and it must be cheap. And this is something that is going to be the next challenge on the distribution and on the collection of data. When there will be a great availability of low-cost sensors, there will be another skip in another jump of this technology. Then open data. I was not sure if it is a good idea to insert also this kind of information. I mean, open data is a great debate. Is the data you're going to collect something that is in the public interest? Yes, no, maybe. But I wanted to add this line just to move the thing and to put the idea somewhere. I mean, everyone is talking about pollution, about the environment, all the environment problems, and the rising of the temperature, etc. And in this situation, all the data that you can connect may help in solving this problem, of course, because the data that you collect in agri-food is data that only you can connect if you're doing this. And of course, it's important for you to understand what the pH of the rain and which is the pH of the ground, and how much water has come down, how much rain there was. So of course it's important for you, but in this environment situation, maybe that this data can be something that goes on the common way. And maybe you can aggregate this data, you can anonymize this data, but it's a discussion that is going on. I just wanted to put this point to check and to have this one idea and just make you think about this. Maybe the answer is not yes for everyone, is not no for everyone, but I think it's maybe for everyone. Let's go to UAV, or unmanned autonomous vehicle. And yeah, I'm talking about drones, robots, farm tractors, stuff like this. You know, there are a lot of work in this already. There are products that are going on the field. I think it is not so easy, for instance, in Italy, because we have an orography problem. Of course, it's very easy to have an autonomous tractor if you have a flat and big field, and this is easy. And when I was living in the US, I was in North Carolina, and you can go for hundreds of kilometers, hundreds of miles, sorry, in the highway, and you were always in the fields of corn, I think, I remember. And of course, it's easy if you have a field like this to use an UAV, but I think we don't have this this so easy in Italy. But of course, is something that we must think about. For instance, drones, maybe that can be very important in precision agriculture. But for instance, when I was working in Trentino, I think that the mountains surely don't help in using drones, because the air is thinner, so they need more power to stay on, and you have the mountains, and you can break the connection from the controlling point to the drone. So it's not easy. It's something that can be a challenge, can be also a change maker, but maybe not with the hype that can be in other situations. Of course, UAV are more interesting also when there's less fragmentation. We have a situation with a very lot of fragmentation of ownership, and so it's something that is going against this, against unmanned autonomous vehicles. But it's something that is going probably to grow in the next few years. And of course must be connected to connectivity, to data, because this vehicle collects a lot of data, etc. The last point, well, I must say that I teach cybersecurity at the university. I have a course on cybersecurity at the engineering faculty. And so I'm a little paranoid about this, so I wanted to add also this information. If someone can hack your actuators or your sensor, you can be in a big mess. So we must try to find a good balance about collecting data, giving data away, share data along the chain, so all the points that I talked before, and do this with the right security. Probably, of course, it's not as hard as in other situations, but it's something that must be kept in account from the beginning. Maybe I'm just a little paranoid, but is my situation. I think it must be considered this. After talking a lot about challenges, I think that I try to give some personal suggestions on methodologies to overcome challenges, or to have these challenges help you to grow. And this is something that comes more from my experience and from my job. I'm not going to go in deep on everyone, but to try to give you some ideas, some information, something that we can discuss later, or something that can just be a motivational rule for you. First point is problem first, technology last. It happens very often that I go in the companies and we start talking, and they say, okay, I want a big data project. And that's wrong. I mean, let's try to concentrate on the problem, listen to your ideas, and then decide which group of technologies is the right choice. is wrong to start and say, okay, I have big data, so how can I use them? That's wrong. You must start from your problem and try to understand in this technology ecosystem, which is the right combination of technologies that can help you. And this is also, sometimes it's also the ICT companies that start from this point and say, okay, I have a blockchain and now I'm going to solve your problem. No, that's the wrong way of approaching this. And another suggestion is keep it simple. Keep it simple. I mean, it is not useful to create a complex framework to solve a problem if you can solve it in an easier way. As starting from the technology usually brings you to a situation where the simplicity comes last, because you adapted the technology to the problem. And if you already decided the technology, you probably will end up with something very complex. If you start with the problem, we start the analysis, and then decide which technology fits in the problem, it's an easier way. Second point, and this is very important in my opinion, I keep an eye on the time, okay, I'm on time, is the ICT as a service. Till a few years ago, when you decided to do something in the ICT world, you buy something and say, okay, I must do this, so I must buy this server, I must buy this software, I must buy this application, etc. And now the world is changed. You can survive without buying ICT. You can buy only access and use. And now we have everything can be in the cloud. You can survive without having a single piece of hardware in your house, and you can also choose to buy different levels of service and decide that your core business is agri-food, is not ICT. So there is someone else that has the core business of ICT. And so you must not lose your energies in constructing an ICT infrastructure, and you can choose, and in my opinion, you must choose to acquire ICT as a service. So try to buy what you need and only the part you need. And this is, I think, where the world is going in the ICT market. This is also because, for instance, if you decide to own your ICT, and you must also keep in mind to keep it updated, to maintain it, etc. It's a stuff that is not your core business. So go and buy services, and I think you'll be happier. And this is another point, is a more philosophical point, but I think it can be interesting. Innovation is never the same. I mean, you must keep an eye on cultural competence, innovativity, context differences, because trying to innovate doing the things like you ever did is not the right way. Analyze differences. Based on this difference, create the enabling environment for innovation. And of course, this is general, it's not for agri-food, but it's something that I think that in the emerging markets, like agri-food, for ICT for agri-food is much more important. Because in my experience, and I hope that nobody that is listening, of the 13 people listening now to me, is going to be offended for this information. But the agri-food field, the agri-food market is not normally is not an innovative market. And it is changing. You have a lot of young people coming in this and that's going to change this. But up to now, it's not an innovative market. It tends not to be very innovative. And so it's very important to have also a methodology on this. And so create the right environment for innovation is important. Just a small sample. When I was working in the Mac Foundation, sometimes you have the people, the farmer, that when you get there with drones or with tablets to analyze the leaves on the tree, they were very not easy. They were not feeling in the right bias. And that I think can be a problem. So innovation must be the culture of innovation must be distributed. If you're going to start with the project, that's another small suggestion. Start with a quick win. I mean, use prototyping a lot, because if you started, if you don't in a not a really innovative market. If you say we are going to do this and we are going to obtain results in the next 6 years, maybe you're not going too far. So having small wins is something that can help you in improve your innovation. Okay, the last one is do not reinvent the wheel. I mean, there's a lot of ICT infrastructure existing. Maybe something that was created for other markets, but that can be adapted to your market. So ICT is here since I think the 90s, and a lot of stuff has already been done. So before creating something, try to see if it's already there, and so do not reinvent the wheel. And also this, I'm saying this for the agri-food is very important, because as I said, is one of the last markets, the last places where the ICT is going to go. I mean, it's only a few years respect to mechatronics or automotive, where ICT is here since a lot of time. This is more new market, it's more fresh market, so maybe you can find something already done from someone else that can be adapted. So this is the first check when you start a project. Okay. Last one, I want to close my presentation, my webinar, with some consideration about blockchain. Why? Because everyone is talking about blockchain, and I would like to give my 2 cents of information and of information and of opinion about what is really the blockchain in the market, and why I think that there is a very high hype on this technology, but in some ways overrated. First of all, I think the blockchain is not the solution. I make this high point, because now it happens too often that I go somewhere and someone says, okay, we're going to solve this using blockchain. Okay, blockchain is not the solution. As I told before, no single technology can be the solution. Every technology must be inserted in a path, and must be something that goes inside a whole solution. So when you say, if someone comes to you and says blockchain is the solution, is only marketing hype. Of course, I'm not saying that is not useful, but I think that it may be a part of the solution or can be part of the problem. It's a complex technology. Is a slow technology now. Is something that was created to handle digital items. It's great for handle digital items. Of course, it's great for cryptocurrency. It's great to handle documents, digital documents, etc. If you try to force the use of blockchain outside the digital world, can be part of the solution, but can become a part of the problem. Because of if you want to use it, there are also other technologies that maybe are easier or less complex, faster, but now there is a marketing hype on this. So someone is trying to say that is the only solution, but it's not like this. So have a great analysis on the real need of blockchain in every project. There are different technologies of blockchain. I mean, the blockchain term is used to describe very different technologies and different objects. There are different vendors, different architecture. So all of this stuff is inside a big umbrella which is called blockchain, but is you must have a very good care in analyzing which kind of blockchain is right for you if you want to use it. There are public blockchain and private blockchain. In my opinion, private blockchain are not a blockchain. I mean, blockchain, it was born as a distributed ledger. If it's not distributed anymore, it's not a blockchain, I mean. But now is a great hype on this, so I will keep it. But just to say that when you say blockchain is not something monolithic, you must have different choices, a different kind of blockchain, open source, not open, and company owned, and this is something that must be analyzed in very high detail. And the last point is where the weakness, the main weakness of blockchain. As I told before, blockchain it was born for digital management of digital items. The very big weakness that I see in using blockchain outside this world is what is called the on-chain, off-chain. What is this? Is when you say that you are tracing something and somewhere this items that you are tracing must be loaded on the blockchain. If it's a digital item, it stays on digital world, so it's easy. But for instance, if you are saying, I want to check to trace my tomatoes from the field to the table, there is the big weakness is when you start using blockchain, and maybe is when you load the box of tomatoes on the first truck, and you start using blockchain and say these tomatoes are starting from here, and okay, from that point, if you seal the box and you have a way to follow the box, and you probably are sure that from that point on nothing has changed, but you cannot be sure of what was loaded in the box. I mean, blockchain is not giving you the truth. Blockchain is saying what it was loaded is remained unchanged. It's not been changed from anyone. Or if there is a change, I keep a track of the change. But if it was false at the beginning, it's false for all the way around. So, for instance, I mean, one of the biggest projects I saw about blockchain now is, for instance, that IBM made for Maersk, which is a Swedish company. I don't remember Swedish or Norway, and is one of the biggest companies in the world moving containers. And the project says, I want to track containers, which means all the documents that follow the container are now digitalized. And all the modal passages from the factory to the truck, to the boat, to the arriving harbor, to the truck, at the arrival point. All the documents are handled in the blockchain. Every change is managed, and if something is wrong, you can understand where this was changed. But there is no absolute warranty that what's inside the container is what you are saying, because the on-chain, the off-chain points are the weakest spot. Okay, I don't want to look like a blockchain offender. It's far from me. But as I see, there is, I think, a too high hype on this item. I just wanted to make a reality check on this. Blockchain is a good technology, is one of the ICT technologies that can be inserted in the ecosystem. I can give you a lot of help connected with IoT, RFID, barcode, chemical, QR code, everything that can help you to handle the off-chain, on-chain point. So if you're doing an analysis and you see that this can help you, that's good, but don't assume that this can be the solution as some companies are explaining now. And okay, a little earlier than I expected, I'm closing here my presentation, and of course I'm opening now the Q&A session. So if you have any questions or something to say, or if you agree or disagree with what I said, I'm here. I'm looking at the chat, and so you're welcome.
Thanks a lot, Massimo. So yes, everyone who has question, please write the question, or if we have time now, maybe open your mic and ask directly to Massimo a question, a comment, or just a suggestion to have more discussion on it.
Hello.
Yes.
I have a question. So I'm Christian Floran from ICT provider. We are working on the Romanian market. Can you hear me, first of all?
I lost the last answer. Are you working for?
On the Romanian market, we are an ICT, Internet and Communication Technology. We have a cloud business. We are selling cloud services for our clients, agri-business, agri-food clients. And I would be very interested to see a solution. So a great presentation, by the way. And I would like to see a solution provided to a client, maybe an Italian one. It does not matter, European one, it would be great. I'm a software engineer at heart, and so I'm a licensed software developer and artificial intelligence master. And I would really like to see a practical solution, so a solution in practice. Okay. And it would be great even if we could speak later on and another day. It's not necessary to be presented now.
I see that among the participants now there is also someone I know from an Italian company that is selling solution to the market. Michelangelo here is listening, and maybe these companies from here, from the Lab is a company here. Michelangelo wants to tell some of your solutions that you created. I know that they work with the company distributing water in Emilia-Romagna, or the distributing agricultural water for Emilia-Romagna, and something more. So, Michelangelo is connected. If he wants to give his contribution.
Okay, great. Michelangelo has written in the chat window, and yes, I will talk with him on the chat. Okay. Oh, later on, actually, he's written me also the email.
Okay.
Oh, okay.
I'm more a consultant. I can tell just some solutions, but maybe that talking directly with the companies that can help. So we can create a connection later, and maybe that also the cluster agrifood can have a list of companies that can extend their experience with you. And I don't know if you are in some European projects, but maybe that this also can create a connection.
Yes, this sounds great. This sounds great. We have specific needs on our market. We have a niche that we are working on for some time now, and we have, for this niche, we have to provide ICT solutions in the area of artificial intelligence. Yeah, all of it, like big data, analysis, everything. Artificial intelligence, machine learning, reporting, and everything. But so we are specialized on a niche, and we like to have a broader view of this field. Thank you.
Yes, definitely. You know that this project is it's done by 5 clusters in Europe. So the Romanian, the Dutch one with Greenport Westland, the Andalou with CTA in Spain, cluster Emilia-Romagna for sure in Italy, and our one VG Police Valley in France. So everyone's here connected who would like to have a better connection for one market. Do not hesitate to come to us. So you all have the reference or who sent you the email for this webinar, so you know well who in your country can make the link with the other country ecosystem and companies. So do not hesitate to ask us the connection with French, Dutch, Italian, Spanish, or Romanian market. Maybe other comment or discussion to have. I see maybe with different context in your own country. I see some Dutch and Spanish people connected, so maybe you could confirm or not what Massimo explained to us.
I left in the last slide, you find my references for every information later. I'm leaving this slide on the screen now.
Yes, and just in the last one, you have the email of Track and our website also. So yeah, thanks.
Okay.
So here it is. Do not hesitate to follow us on Twitter. We put some update of event where we go and where we are meeting people. The website for all the update and news, and for sure for the next webinar will be communicated there, and the record of this webinar also. And for contacting us or directly to each cluster that you see the logo on the right, or directly to this email. So I'll let you 1 minute more if you have question or suggestion. If not, we will conclude here. Okay. If no one, if no one are more question, we will conclude here. And thanks again, Massimo, for your presentation and your time. And I hope that it was very fruitful for everyone to listen to you today.
Thank you to you all.
Thanks again. Bye-bye.
Bye-bye.